Welcome people. In this video we are going to look at mathematics paper 1 for the year 2023, and this paper was written by the external candidates. Let's have the first question. Evaluate 3 squared plus 3 raised to the power negative 1 times 2 raised to the power 0. Okay, so to evaluate simply means to find the numerical value. So we need to find the actual number from here. We'll begin with 3 raised to the power 2. 3 raised to the power 2, it means we have 2 3's. So please never make a mistake where you multiply 3 times 2. No, this means we need to multiply 3 times 3 2 times. Then we have an addition sign here. We are going to change this 3 raised to the power negative 1. We have to make it a positive, so we need to change the index as a positive. How? We write as a fraction 1 over 3 raised to the power 1, which is same as 1 over 3 times. Then we can see that 2 is raised to the power 0. So whenever an expression, whether a number or a letter, is raised to the power 0, it is equal to 1. Okay, we can now expand here. 3 by 3 we get 9 plus 1 over 3 times 1 is still 1 over 3 over 1. You can see that we are dealing with a fraction with addition, so we need to find the lowest common denominator. The lowest common denominator for 1 and 3 is 3. 1 into 3 times 7 we get 27, plus 3 into 3 is 1 times 1 1, which is 27 plus 1 is 28 over 3 as our final answer. But if we want to leave it as a mixed fraction, we'll say 3 into 27 will give us 9, remainder 1 over 3. Then there is another way in which we can handle this part here. We said we have 9 over 1 plus 1 over 3. Okay, let's say maybe finding the lowest common denominator is an issue for you. So what you can do is you can just get this number, you multiply by this number. Then this number you multiply by this number here. So we can begin. 3 times 9 will give us 27 plus 1 times 1 is 1 over, you multiply 1 times 3, which is 27 plus 1 is 28 over 1 times 3 is 3, which is giving us the same 9, remainder 1 over 3. We go to question 2. Question 2, we are told to simplify. To simplify, it means we need to make it simple. We have this expression 2 open brackets x plus 3y minus 4x minus 2. So we need to get rid of the brackets. So whatever number or letter that we have outside the bracket must multiply everything. These two will multiply with x, step 1. Then the second one we have to multiply by 3y, and make sure you put into consideration the signs. 2 is positive times x positive, which is giving us 2x. Then 2 times 3y will give us 6y. We are done with the first party. We move on to this party. Negative 3 times positive 4 will give us negative. 3 times 4 is 12x. Negative 3 times negative 2 will give us positive 6. Do we have the like terms? Yes, we have the like terms. 2x minus 12x. We collect the like terms. Then here we are going to subtract, since we have different signs, and as usual we get the sign from the bigger number. 2x minus 12x will give us negative 10x plus 6y plus 6. This is our final answer, because what remains there are like terms, so we can't add or subtract those. We move on to question 3. Factorize completely. We have 3x squared minus 27. Okay, so begin by, first we need to take out our greatest common factor, which is 3. 3 can go into 3x squared and also into 27. So we write our 3. What else? We can see that we only have 3. We open brackets, then we divide 3 into 3x squared. These 3 will cancel, giving us x squared minus 3 into 27 is just 9. Make sure that after you factorize, if you are to expand, make sure you are able to get this expression. And we can see that if we are to expand, if we are to say 3 times x squared will give us 3x squared, 3 times negative 9 will give us negative 27. So this is just to give us the picture that at least what we are doing is making sense. Now the inside part can still be factorized further, because 9 can be written as 3 squared. So we need to use the difference of perfect square number. Now, what is the formula? Let's say, for instance, you have a squared minus b squared. How can you factorize this? You have to open 2 brackets. Then since there are 2a, you write your a here, the other one here. One bracket we have plus, the other one minus b. And it doesn't matter which bracket has a negative or positive. You can put, it doesn't matter. The key point is you just have to obey the concept of having 2 brackets. So we'll do the same to this point here. We open 2 brackets. Then here we write 1x, also 1x, plus, minus 3. So this is our final answer. We move on to question 4. Find the gradient of the line which passes through the point -3, -1. The other point is 0,3. This is our x1, x2, y1, y2. The formula for gradient is y2 minus y1 divided by x2 minus x1. So let's do the substitution. Y2 is 3 minus y1 is -1 over x2 is 0 minus -3. M is equal to negative times negative is +1 over negative times negative is 0 plus 3, which is 3 plus 1, we have 4 over 3. 3 into 4 is 1, remainder 1 over 3 as our final answer. And if we want, we can also find the same gradient, or maybe I can say, it doesn't matter the one that you choose to be the 1s or the 2s. So if I want, I can say this is my x1, y1, x2, y2. Doesn't matter, the answer will always be the same. Let's give it a try. Gradient is equal to y2 minus y1 over x2 minus x1. Our new y2 is -1 minus y1 is 3 divided by our x2 is -3 minus 0. -1 minus 3 is -4 over -3. Negative will cancel. 3 into 4 is 1, remaining 1 over 3. we can still get the same answer. So it doesn't matter which pair you choose to be ones, the answer will always be the same. Just wanted to give you a clarity. You may need it. We move on to question 5. Shade A union B intersecting C complement on the Venn diagram in the answer space. Now for a problem like this one, I think you may need to draw another Venn diagram. Now in this Venn diagram, you can use numbers of your choice so that we have some elements. Maybe we see what we are looking at here. So we use 1, 2, 3, 4, 5, 6, 7. Now with these elements, let's first begin by finding A union B. So A union B, we just want to combine the elements of A with those of B. From A we have 1, 2, 5, 4. Then B 2, 3, 5, 6. So by following the order, we have 1, 2, 3, 4, 5, 6. So this is the element of A union B. Then what else? Let's find the element of C. The element of C is 4, 5, 6, 7. Now going back to our question, C has a complement. It means all elements in C must not be part of our solution. Now we can cancel element C in C. Maybe before we do that, let's go back to our question. So the question is A union B intersecting C complement. So we want the element C in A union B except C, as long as, because if you look at the intersection is something that is common. So the elements in C, including those that are common in A union B, must not be part of the answer. So let's look at that. 4 is in C and also in A union B, so we can cancel it. 5 is in C, also here we cancel it. 6, also here we cancel it. Even 7 is not needed. So what numbers are there? 1, 2, 3 are numbers that we want. So that is where we are going to shade here. So maybe that is what you need to do here. We move on to question 6. The position vector of a point P is 3, 4. Given that the point Q is -1, 1, find PQ. Whenever we have position vector, it means that the vectors are originating from their origin is O. So we are going to draw 2 lines. We'll say this is vector P, and this is vector Q. They are all originating from here, since of this position, the word position. Then we'll put the arrow. So this is same as vector OP is 3. Shouldn't put the division sign here. 3, 4. Then the vector OQ is -1, 1. Now how can we find the vector PQ? We can use this principle. We need to start from P. So from P to Q, what are we supposed to do? We'll say PQ is equal to, we'll move in this direction, PO plus C OQ. PO is 3/4. I mean it's 3, 4. Now before I forget, look at this. OP is 3 over 4. PO, this is same as we are moving against the direction, so we need to introduce the negative to 3 and 4. So we are going to have negative 3 minus 4, since we are moving against the arrow, plus here we are going to have negative 1, 1, like this, which is now, here we have negative 3, positive times negative is negative 1. Here we have negative 4 plus 1, which is we are going to add negative 4 minus 3. This is our final answer for vector PQ. And if we want to give this answer in coordinate form, this is negative 4, comma, negative 3. So we just leave it in the column form. Okay, we move on to question 7. Given that matrix P is equal to 4, negative 1, 0, 2, 0, 3, and Q1, 2, 3. Let's find the order for matrix P. The order, row 1, row 2. So it's 2 by the columns 1, 2, 3. So it's a 2 by 3. The Q has the order of 1, 2, 3. So order is 3 by 1 because there are 3 rows and 1 column. Now the first question is we want to find the transpose of matrix P. So what are we supposed to do with the transpose? We just need to change the rows of the first matrix becomes the columns of the transposed matrix. So the row is this one. This is our row 1, which is we write our 4, negative 1, 0. Then the second row 2, 0, 3. Okay, this is our final answer for the transpose. It is just a very easy question. Now we move on to multiplication. PQ. So first begin by writing the matrix for P. Then Q. We are going to use now row by column. This 4 will multiply with 1 plus this negative 1 multiply with 2, this 0 by 3. Then we do the same with these 3 numbers. 2 times 1 plus 0 times 2 plus 3 by 3. Four times 1 is 4. Negative 2 plus 0. 2 times 1, 2 plus 0 plus 9. Which is our final answer. 4 minus 2. 4 minus 2 is 2 plus 0, which is 2. 2 plus 0 is 2 plus 9, 11. So I'm getting 11 as my final answer. Now let's go back to our question here. If we look at the order of P is 2 by 3. Then the order of Q is 3 by 1. So if we want to know that the multiplication can be applied under given matrices, the number of columns in the first matrix must be equal to the number of rows in the second matrix. Look at this. This is the number of columns in the first matrix equals the number of rows in the second column. Then multiplication can be applied. Then the other 2 outer numbers gives you the order of the new matrix, the product matrix that will be formed. So the product matrix that will be formed is a 2 by 1, and we can see from the answer we have a 2 by 1 because we have 1 row 2 rows, so we have 2 by 1. Okay, so that is what we can look at here. Then we move on to question 8, and we are going to consider question 8 as our last question for this video. We have numbers 1, 7, 13. Find the 8th term. So term 1, term 2, 3, 4, 5, 6, 7, 8. We want the number that is on this position. So for us to find this number, we need to find the common difference. Common difference is given by second term minus first term, or third term minus second term, like that. Second term is this number 7 minus first term is 1. 7 minus 1 is 6. So it means they were adding 6 on each term to form the next term. 1 plus 6 is 7, plus 6 13, plus 6 we have 19, plus 6 25, plus 6 31, plus 6 37, plus 6, this should be 43. 43 is our 8th term. Or if you want, we can use the nth term formula. Tn is equal to a plus n minus 1 times common difference. So Tn, since we are solving for 8th term, n represents the number of terms. A is our first number, 1. Then here we are going to have 8 minus 1. Common difference is 6. Here we are going to have 7. So if we multiply 6 times 7, we get 42. 42 plus 1, we still get 43 as our final answer. Then for B, sum of the first 15 terms. Sum is given by this formula. Please make sure you commit this formula to memory. So for this question, n is equal to 15, since we are solving for 15 terms. Our first number is still 1. 15 minus 1 times z. Common difference is still the same, 6. 2 times 1 is 2. Plus here we have 14 times 6. So how can we multiply 14 times 6? So we say 6 times 4 is 24. We keep the 2. 6 times 1 is 6 plus 2, 8. So 14 times 6 is 84. We have 15 over 2. 2 plus 84 is 86. Now 2 here is 1, 2 here is 4, 2 here is 3. So we have 15 times 43. Okay, so you can just use the old way of multiplication. 15 multiplied by 43. 3 times 5, 15 carry 1. 3 times 1 is 3 plus 1, 4. 4 times 5, 20. We keep the 2. 4 times 1 is 4 plus 2, 6. Then we do the addition. 5, 4. So my final answer is equal to 645. So this is what I wanted us to share for this. So that's it for this video. If you find this video interesting, give it a like and comment in the comment section below. Thanks for watching.